The last type of case that we're going to see sometimes when we're working with adding and subtracting rational fractions is when or rational expressions is when they show up in things like what we call complex fractions. We've seen complex fractions before, and if you remember, what we have here is we have what's on the top, so kind of that thicker bar in the middle, what's on the top is being divided by what's on the bottom. So if we wanted to write this a different way, we'd have 4/9 plus 3/4 on the top, and we're dividing that by 5/6 plus 2/3 on the bottom. So when you first see a complex fraction, the first thing you want to think of is stop. Think of it as two different expressions that are being divided. Once you've done that, we have rules for dividing with fractions, and it's all about multiplying by the reciprocal. But the problem is that's a rule for dividing two fractions. And what we have we have things being added together here and things being added together here. So before we can even think about doing a reciprocal, we can have only one fraction here and one fraction here. That means that I've got to add each of these. So let's do that. In order to add and subtract fractions, remember we need a common denominator. So between 9 and 4, I'd say my new denominator would be 36. So let's take a second and rewrite this expression with 36 on the denominator. To get from 9 to 36, I'd have to times by 4, so I times the top by 4, and I get 16. To get from 4 to 36, I'd have to times by 9, so I have to times the top by 9 to get 27. I haven't changed anything in the problem. All I've done is just rewritten an equivalent fraction with a common denominator. Now that the denominators are the same, I can go ahead and add the tops. 16 plus 27 gives me 43, and I have 43 over 36 as my first fraction. Now I need to work on the second fraction. Here I have 5/6 and 2/3. I can get both of those denominators to have 6 on the bottom. The first fraction already has a 6, and I can get the second fraction to have a 6 by multiplying by 2 on the top and on the bottom. So 2/3 and 4/6 are the same thing. The next thing I want to do here, notice my denominators are the same, so I can go ahead and add those fractions together. Keeping the bottom of 6, I can add the tops and I can get 9. And now what I have is a division problem of two fractions. Now that I have a fraction divided by a fraction, I can go ahead and multiply by the reciprocal. I had 43 over 36, keep the divide, or change the divide to times rather, and then flip the second fraction. I have 6/9. Now you may have noticed this fraction could be reduced. That's fine. You could have done it earlier. You can do it now. It doesn't really matter. But at this point, what we're looking for is, are there any common factors we can divide out? I do notice that 6 goes into 36 evenly, so I can just do that. 6 goes into 6 once, and 6 goes into 36 6 times. 43, nothing of 6, 3, 2, 3, 9, none of those numbers can go into 43. So I'm just left with 43 on the top of my fraction, and then on the bottom I have 6 times 9, which is 54. And that would be my reduced fraction answer. So that's essentially the process when you're working with complex fractions. We want to do everything on the top divided by everything on the bottom, and if the top and the bottom aren't one fraction, we have to do that first before we can deal with the division. Let's try this one step a little bit trickier, but not too bad. But let's add in some variables into this. So same deal here. I see a complex fraction and I hate it. So what I want to do is rewrite this as a division problem. So it's everything on the top, so 3 plus 5 over x, divided by everything on the bottom. That's a division. Let's try that again. Divided by everything on the bottom, which was 2/3 plus 1 over x. Okay, I'd like to divide these, but before I can, I need to add each of these so that I end up with a single fraction. Right now, this is 3. You can think of that as 3 over 1. My common denominator that I need to be able to add those fractions, it's pretty easy to get that to be x for each of my denominators. So let's rewrite that fraction with x on the bottom. For the first fraction, I'll need to multiply by x, top and bottom, so I end up with 3x on top. For the second fraction, it already has an x, so I will just leave it the same. Now that the denominators are the same, I can add the tops, and I'm left with 3x plus 5. I can't actually put those together because they're not like terms. So this is all I have that I can do at this point for this first fraction. Now, this may not look a lot better than what I started with, 3 plus 5 over x, but it's tons better because now it's just a single fraction, and that's really important for me to be able to proceed. Now, let's go and do the same thing on the other side. First thing, I'd like to be able to add these two fractions into a single fraction. To do that, I need a common denominator. Between 3 and x, my common denominator will be 3x. That's the best I can do, is just multiplying those together. For the first fraction to get from 3 to 3x, I'll need to times top and bottom by x. So I end up with 2x on the top there. For the second fraction to get my common denominator, I'll have to multiply by 3. 1 times 3 gives me 3 on the top. And now that I have a common denominator of 3x on the bottom, I can go ahead and add the top. So I have 2x plus 3. Okay, almost finished with the problem. Now that I have one fraction divided by one fraction, I can rewrite this as a multiplication problem. So I'll have 3x plus 5 on the top divided by x, change the divide to times, and then I want to flip the second fraction over so I can multiply by the reciprocal. So I end up with 3x over 2x plus 3. If it helps you to think of these things all in parentheses as factors, that's fine. You can do that. There's a 3x plus 5 on the bottom, or on the top, but no 3x plus 5 on the bottom, so I can't do any reducing here. This 3x and x, we could divide the top and bottom by x here, and that's okay because these aren't next to plus signs. They're part of what the factors are. So if I divide the top and bottom by x, those will actually go away. And what I'm left with is 3 times 3x plus 5 on the top, and on the bottom, I have 2x plus 3. No other canceling can go on here. This is a group of terms, and it needs a complete match of 2x plus 3. I can't cancel the 3's out because of the plus right there. So that's all you can do. You can stop right there. Or if you happen to multiply things out while you were doing that and distribute it, the other acceptable answer would be 9x plus 15 on top with that 2x plus 3 on the bottom. But you can't reduce that any farther because there are no common factors in that expression.